Homework 2, question 1. What is the group that distinguishes alcohols from other classes of compounds? Well, the alcohol group is actually a hydroxy group. So hydroxy is going to be the answer there. Number 2, identify the correct statement with respect to the oxygen found in an alcohol as compared to the oxygen found in an ether. Well, the first statement that I have, oxygen is similar in both compounds as it is always found on a terminal carbon. That is incorrect. Oxygen is identical in both of these compounds. The difference between them is determined by another factor. That's a confusing statement. The oxygen in an alcohol is going to be bonded to a carbon as well as to a hydrogen, but the oxygen in an ether is going to be bonded to two different carbons. So I'm going to say it's not quite identical. The oxygen in an ether is found on a side chain and the alcohol is not. That is incorrect. So it is the oxygen in an alcohol is directly associated with a hydrogen, and the oxygen with an ether is not chemically bound to a hydrogen. That is the correct statement. Question number 3, what is the correct IUPAC name for this compound in this image? Well, when we look at that image, what we're going to do is number this so that the carbon with the alcohol group, with the hydroxy group, is carbon number 1. So this is going to be carbon number 2, 3, 4, and 5. So we know we have a cyclopentanol, so it is not going to be either of these. It's going to be one of these answers here. Now when we go to name this, so we're going to name it cyclopentanol, and the 1 goes with the cyclopentanol. So it's a 1-cyclopentanol. But because we have that alcohol group, that that 1 is kind of defined by the OL. We know that. So it's going to be a 2, and that is a methyl group. So that is a 2-methyl cyclopentanol. Number 4, which of the following compounds is classified correctly as a tertiary alcohol? Well, let's snip that again. And let's draw these real quick. So what we have is 3-methylbutanol. In fact, all of these are butanols. So if we go like this, A, B, C, and D. So A is 3-methyl-2-butanol. Here's 2, here's 3. 2 is 2-methyl, 1-butanol. C is 3-methyl, so we have 1, 2, 3-methyl, 1-butanol. And D is 2-methyl, 2-butanol, like this. So here, the alcohol group is bonded to a carbon that is bonded to 2 other carbons. So this is a secondary alcohol. Here, the alcohol group is bonded to a carbon that's only bonded to 1 other carbon. So that's a primary. This one's also primary. And this one is tertiary. Now, the question asked us, which is tertiary, so that's going to be the 2-methyl-2-butanol. Number 5, which compound would be most soluble in water? Well, we need to look at our functional groups. So my A has an alcohol functional group, B is an ether, C is an alkane. It has no discernible functional group. D is also an ether. The answer is going to be the alcohol because it can hydrogen bond. Remember, hydrogen bonding occurs when you have a hydrogen that is covalently bonded to an O, N, or F. Alcohol fits that description. Number 6, which of the following alcohols would be the most difficult to oxidize? Well, when we oxidize, what we're doing is we are adding a carbon-oxygen bond. So to be the most difficult to oxidize, we're looking at 1, 2. Okay, so all of these are alcohols. Why don't we draw these out? So A, I have methanol. I'm just going to draw it like this. B, I have CH3, then a CH that has an OH. CH2, CH3. CH3. So this is a secondary alcohol. Here's a primary alcohol. C is going to have this kind of structure. So we have two primary alcohols. And then D, we have CH3, COH, CH3. So we have a tertiary structure here. So the tertiary structure is going to be the most difficult to oxidize because this carbon doesn't have a labile hydrogen to be removed in order to make a double bond here. So it's going to be D, the tertiary alcohol, or D on my iteration of this quiz at least. Number 7, the phenol in poison ivy sap that causes skin on some people to blister. That is this compound, urushiol or something along those lines. I'm not sure. Number 8, select the correct IUPAC name of this compound. When we're making an IUPAC name, we need to find our longest carbon chain. Now, although this is an ether functional group, this oxygen that is single bonded to two other carbons here, we need to find our carbon chain with the most carbons in it. So I'm going to number, and I'm going to number it this way: 1, 2, 3, and 4. So this is a butane. So I can eliminate the pentane and the ether. Remember, the word ether is used for common names, not for the IUPAC name. So this is a butane, and I started the numbering here at this carbon because it is attached to our functionality, and this is a methoxy group. So we have a 1-methoxy 3-methyl butane. So that is how we would name that compound. 1-methoxy 3-methyl butane. Number 9, oxidation of a thiol. Remember that a thiol is the sulfur analog to an alcohol. So when we oxidize a thiol, what we're making is called a disulfide compound. Number 10, which of the following compounds would you expect to be foul smelling? Well, we would expect thiol to be foul smelling. When you see the word thiol, think skunks, because that is the compounds that smell with skunks are thiols. Number 11, dehydration of an alcohol will produce what? Well, the dehydration of an alcohol, what dehydration means, so if we have our alcohol here, have our OH, we have our H. Dehydration means we are removing a water molecule. And when we remove that water molecule, what we end up with is an alkene. Alkene is the answer to number 11. Number 12, if one hexene is hydrated in the presence of hydrogen ions, which would be an acid, which of the following would be the product? Hydration with an acid. So hydration is the adding of a water molecule. And if we have one hexene, which looks 1, 2, 3, 4, 5, 6, one hexene looks like this, we're going to be adding a water molecule across that double bond. This is a Markovnikov addition. It can be syn and anti, so it can come from the same side or it can come opposite, syn or anti, but it is a Markovnikov addition. That means when we add the water molecule, we're going to add the water part, the alcohol part, the OH, to the most substituted carbon. So the OH goes here where the H goes here. So then our product is going to be this 2-hexanol product. And in the written out form, I'm looking for the OH here. It would be D on my quiz. So it's going to be C on this quiz. I'm looking for the OH. Nope, I'm right. D on this quiz. I don't know what I'm thinking here. Number 13, what's the IUPAC name of this compound? Well, let's draw this out. So this compound, we have an OH here on the end. Change my color. Then we have 1, 2, 3 carbons. Well, 1, 2, 3. And then we have an OH on this end. So we've done the OH, we've done the CH2, then we have this part, CHOH. And then the third part is CH2OH. So this is 1, 2, 3 propane triol. So there are 3 alcohol groups on each carbon of propane. So it's propane triol, 1, 2, 3 propane triol. Now the common name for that is glycerol, but we're looking for the IUPAC name. Number 14, what structural characteristic is shared by aldehydes and ketones? Aldehydes and ketones have no shared characteristics. That's not true. They both are straight chain compounds. Again, not necessarily true. Aldehydes and ketones both contain carbonyl carbon. That is true. The carbon double bonded to an oxygen is called a carbonyl carbon. And then both of these compound classes have the smallest compound of 5 carbon skeleton. That is not true. Number 15, what's the IUPAC name for this compound? Well, IUPAC name, we find the longest carbon chain. There are 4 carbons in this chain, 1, 2, 3, 4, and it ends with a functional group, and that functional group is an aldehyde. Because it ends with an aldehyde, we know the Al is at the end, so we know this is a butanal. Carbon 1 is defined as being the carbonyl carbon in an aldehyde. So 1, 2, 3, this is 3-bromobutanal. Number 16, what's the IUPAC name for this compound shown? Again, IUPAC name, we are looking for the longest continuous carbon chain that contains our functional group. And in this case, it is a ring structure. So this is a cyclobutane. But because we have this carbonyl structure, and the carbonyl structure, or the carbonyl carbon, is bonded to 2 other carbons, and they are not carbonyl, then we have a cyclobutanone. Now, the carbonyl carbon will be defined as carbon 1. Then on carbon 2, we have a methyl group. So this is 2-methyl cyclobutanone. Number 17. Assuming that molecular weights are comparable, which of the following compounds would you expect to be the highest boiling point? Well, the one that has hydrogen bonding. That would be an alcohol. Number 18. Which of the following products is formed when hydrogen is reacted with 3-methylbutanone? Well, let's draw it. So 3-methylbutanone. Here's my butane. It's a 2-butanone, which means that's where my carbonyl is. 3-methyl. So it's going to look like this. So what is formed when hydrogen is reacted with this? Typically, when we have hydrogen, we also have something like palladium or platinum. And that is a reducing situation. And with organic compounds, when you're reducing, what you're doing is you're reducing the number of carbon-oxygen bonds. So if we reduce the number of carbon-oxygen bonds by 1, and we happen to add hydrogen to that oxygen as well, what we have formed is a secondary alcohol. Now, if we wanted to be thorough, we would name this secondary alcohol, and this would be 2-butanol. Oh, I just realized I am off the screen. Sorry about that. So this would be 2-butanol, but then we have this substituent to name as well. So this would be 3-methyl-2-butanol, and that is a secondary alcohol. Number 19, predict the resultant compound class when an aldehyde is hydrogenated. Well, when we hydrogenate an alcohol, we are again reducing. What we're forming is an alcohol. When we hydrogenate an aldehyde, we form an alcohol. It happens to be a primary alcohol because that carbonyl carbon is on the terminal carbon. Number 20. Hemiacetals are what? Well, hemiacetals are the unstable product of the oxidation of an aldehyde. 21. What is the result of a hydrolysis reaction? Well, a hydrolysis reaction will split a molecule into component substances. Number 22, what class of compounds does glucose belong? Well, glucose is a cyclic hemiacetal. Number 23, which of the following compounds upon hydrolysis will yield ethanol and propanol? So ethanol looks like this. We have 2 carbons and an OH. And propanol looks like this. So we have 3 carbons here. We have 2 carbons here. So the first thing I want to do is I want to count how many carbons I have. I have 1, 2 here, and I have 1, 2 here. So it's not going to be A, just right off the bat. So 1, 2, 3 carbons here, a bunch of oxygens, 1, 2, possible. 1, 2, 1, 2, 3, again, possible. 1, 2, 3, 1, 2, 3. It is not going to be D either. So immediately I have crossed out 2 of my answers, and I only have to analyze B and C. So let's draw those out real quick, and then we'll find our cleavage points. So here we have a CH3, CH2, CH. Okay, so there's my 3 carbons. Then I have an OH and an O. So that tells me I have an OH here, and then I have an ether O here, and then I have 2 carbons, 1, 2. That is compound B. Compound C is going to look like, let's see, we have a CH3, CH that has an OH. So that takes care of that. Then we have our ether, oxygen, and 3 carbons, 1, 2, 3. Now our cleavage point is going to occur between the ether oxygen and the carbon that contains the alcohol group. But it's not quite as cut and dry as that, because what happens is, I'm going to choose green here. This alcohol group doesn't stay as an alcohol group. What happens in hydrolysis is that the hydrogen here is removed. And that when that hydrogen is removed, these electrons fall, which is what breaks this, which is what creates an H, which comes after what creates an oxide and a charged oxygen, which comes after that H. So what we form with B is going to be, and here I went and drew ethanol. What we form with B is going to be the ethanol. 1, 2, 3. Nope, that's propanol and ethanol. Okay, so with C, again, hydrolysis, when hydrolysis happens, we have this hydrogen being removed, the electrons fall down here, we make ethanol, these electrons fall to the oxygen, which comes to pick up a hydrogen. 1, 2, 3, 1, 2. So here we have formed propanol, 1 propanol, and ethanol. So we need to look at what were our products? Well, our products were ethanol and propanol. So B is going to be our answer for this one. And number 24, hydrogenation of an aldehyde will produce what? Well, when we hydrogenate, we're going to form a primary alcohol because hydrogenation is a reduction reaction. So we are reducing the number of carbon-oxygen bonds. When you have an aldehyde, that carbonyl carbon is terminal. So we remove one of those carbon-oxygen bonds, it becomes an alcohol. It's a primary alcohol. And number 25, fully reacting an aldehyde with an alcohol will produce an acetal.